So, first of all, thank you very much for your opportunity to present my work. I say my work, but it's the work of my team. And I'm going to, to present how machine learning techniques can help to analyze presidential campaigns. So I'm not going to talk about the current one because we are still collecting data, but I'm talking about a Spanish one that occurred in 2018, 2 years ago. So not the American current one. So just to present myself, I'm associate professor of innovation, technology and data science at La Salle, Ramon Llull in Barcelona, Spain, Europe. I'm a researcher in data analytics and digital transformation. I'm author of several scientific publications. And one of my field of application is smart cities. I'm also evaluator of a Smart City World Congress that occur normally every year. And I'm finalizing a book about how to implement data-driven cities that should be published early 2021, sorry. You hear me very well? Yeah? Okay. So far so good, I think. So I'm carrying on. So what is the context of my research? As you know, social networking like Twitter, Facebook, Instagram, is a very popular communication tools for millions of users, and they are platform very easy to use with free format. And so with this communication, you can express your opinions that could be political or religious opinions. And so it's an avalanche, it's a massive data that are circulating and that are an opportunity to be collected. And why? Because this data can be used to try to understand what is occurring in a country, what is occurring in a campaign, in a political campaign, etc. So the goal and what I'm going to present today is how the use of statistical and machine learning methods can help to explore the content related, in that case, to a political presidential campaign in 2018. Okay, but it could be the same for, I don't know, for a private campaign regarding sustainability. But I'm trying to say that it will be the same process. But we will do it in that case, talking about this political presidential campaign in Spain. So I have 20-25 minutes, if I understand well. So I will present my what are the research contributions, and I will talk about first the result that we have collected using different statistical tools, and also the result of one of my paper where we were able to infer, to predict the presidential votes and to predict the sharing vote between the different candidates. Okay, so that's the focus of today. So what are the research contributions and what the machine, how the machine can help? So our contribution using artificial intelligence are to structure the messages carried out in a very noisy Twitter free writing style. As you know, in Twitter, you can write 140 words in a format that you want. So it makes very difficult to analyze. And so we will structure these messages, and structuring this messaging, the goal will be to define the main topics associated to each party, their evolution during the campaign, because maybe as we will see, the candidate can change the strategy of communication. And then we will conduct diverse machine learning analysis to measure the public opinion, the polarity, if people are happy, agree, disagree about an opinion of a candidate. And finally, using all this data and training different machine learning systems, we have tried to predict the result, and we get some good result, as I'm going to present later on. I'm receiving some noise in the line. I hope that everything is all right. Otherwise, it's somebody that I'm just reading yeah, thank you. So let's talk about, of course, the objective is not to present everything, but just, I think, just the outstanding result, and especially the what was our main result. I'm not going to present all the methodology. So first of all, just to explain you a little bit how we collect data and how these data were used. So the collection of data, for those that know Twitter, was based on using the API, the application interface developed by Twitter, that allow to capture public data in real time. And we use different hashtags, you know, these labels that it is used in social networks, that users use to place and categorize the tweets. So we use different hashtags during the campaign, and using this hashtag, we were able to collect tweets data related to the context of what we want to analyze, which is the campaign, okay? Which is very important to have this hashtag, to be sure that we are collecting what we want to collect and not another phenomenon. So we collect like 1,200,000 tweets, so 1,200,000 tweets regarding all the campaign, all around 16 days. Of course, as I said, it's a noisy tool, so there is a big preprocessing process, cleansing, norming, stemming the data, and finally to convert this unstructured data to a vector and a corpus of vectors. So that's the result, and that's I think could be interesting. First, as you can see, figure 1 is the two debates. Now, first, as you can see that there is like an evolution, no? And like peaks, and the peaks are perfectly aligned with the debates that, of course, are generated more interest. Second, as you can see in figure 1, the red one, which is the left party, is still on the top, which means that during all the campaign, the left party was generating more enthusiasm. And actually, it was the winner was the left party. So there is still like a correlation. If we look at tweet 2, so we see the same thing in figure 2. We see that Sanchez, the left party, is still on the top. And Abascal, which is the far right party, the black one, is on the bottom, and he was the last candidate. He was the candidate who has the smaller voting share. If we look at figure 3, what we can see is that there is some candidate that generate at the beginning expectation, but this expectation decrease around the campaign. You know, like the blue one, which is the far left party. So you see the blue one is generating some expectation. There is a top day 16, but progressively he decreased. You know, it was the first time that this party was competing in this campaign, this presidential campaign. So at the beginning, generating a lot of expectations, tweets, but at the end of the day, it has decreased progressively to the end. If we look finally figure 4, we can see that we have the number of retweets, and we see that the far right, which is the black one, has generated a lot of retweets. Means that it's not generating so much tweets, figure 2. It means that what he's saying is not generating a lot of enthusiasm by his fans, but his message, which is usually the message of the far right party, are generating a lot of debate, a lot of discussion, a lot of people that disagree, you know. And actually, I think he was looking for that. So that's the reason why we see that figure 4, the number of retweets is higher than if you look at the number of direct tweets, which is figure 2. Okay, so and so on and so on. I'm not going to go more into details, but just to tell you what we can do with a free messaging system. That, because again, I forget to say this, is completely free. So look at the added value you can get with a free messaging system. Then you can look at workload. I mean, nothing very hard to do. So if you look at the left party, if you look at the main frequent words, they talk, it is in Spanish, but they talk about their motto, which is hacer querer, which is the motto, the main topic that we are using in their campaign, but also derecho. Derecho means right. And there was a lot of big debate in this campaign about the right for the woman. So it is completely expressed in this word cloud. And we have done the same thing for the rest of the candidates, as you can see in my screen. Yeah, I'm happy to share this result with the attendees, but I think I want to show you, to give you an overview of everything. With the frequent words, we try to look at what were the frequent words by candidate. Okay, and I give you translated in English the main words. So the left party was Spain needs to move forward. Spain needs to go ahead. Right party was that the focus has to be how to decrease the unemployment. Okay. So right center was we need change. We need a future for Spain. we need to move from this this polarization between left and right. The right center was calling for change in Spain, that we need to make a government in the center. Far right was talking about the nationalism, the big Spain that was lost, the spirit of Spain, etc., etc. And far left talking about a referendum, different proposals, constitution also, etc., etc. So that's the frequent words that have been used by the candidate. There is no transformation so far. It's just collecting the frequent words. Then we try to use techniques to look for topics non-observed, you know, try to reduce the dimensions of the tweets. It was a lot of dimensions, to reduce it to a small number of dimensions, which is usually done by LDA techniques. And in that case, as I said, we use Larix-Dirichlet allocation techniques. And I'm not going, this is part of my presentation for my students. For you, I'm not going to go in, of course, in that consideration. But let me show you the result, for example, for the far left. You see, so there is far dimensions, as you can see. And for each of the dimensions, we have the salient terms, which means that the terms that has the highest probability to belong to these dimensions. So if we look at dimension 5, you have this this set of words that are on the left, on the right, sorry. Okay. So again, we try to look for at that moment using the machine to look for latent information, latent message. It's impossible for the human being to analyze 1,200,000 tweets. The machine should help us to do it, and I think it's there is a lot of expectation. Part of the answer we have it. We are able to do some things, but this kind of research is still under investigation, you know, because there's still some room to fill. So yeah, so we do this, and finally, we look for sentimental analysis. We look for analyzing the sentiment of each tweet. So there is tweet that have a positive sentiment, means that they are positive opinion. I like this candidate. There are tweets that have negative opinion, which means that, for instance, I hate this candidate, and neutral. I don't like, and I will do nothing, for instance. I'm undecided voter, so which is neutral sentiment. So how do we make this sentimental analysis? We developed a neuronal network that we train using an existing data set developed by a Spanish Society for Natural Language Processing, and with these tweets that are existing by categories: political, economy, football, etc. That we have the polarity. Okay, so we were able with this data set to train our network, our neuronal network. And then we inject our tweets in that neural network, and the result is this TensorFlow that I'm going to load for you in direct. So you can see we are using convolutional network. We are in the future, we want to use LSTM architecture, which is a recurrent network. Today, I'm just going to present the convolutional because it's much more mature. But in our team are working on the LSTM architecture also. So let me just load the embeddings. Sorry. As usual, when you make a demo, doesn't work at the first time, but it's the reason why that is not only a PPT. Okay, so look at this. This is a TensorFlow. We see, I'm going to freeze now the window. We see the three polarities, positive, negative, and neutral. We still need to clean more our system, to train better our system, because we have still some words that have not clear polarity, but our system was able to train the polarity of each single tweet with a good total variance of 80%. Okay, so what for? What else? What do we do with this? Our purpose, and this is the paper that we have published, is to infer the result of a campaign. So the voting intention inference is approached as a multiple regression analysis. So we use 7 variables to train our system. So one of them is the sentiment score per tweet. So the result of the last research. And we use also some quantitative information, as I showed you before, a positive, negative tweet volume, positive or negative base Twitter user number, etc., as you can see on my screen. So how do we train? We train our machine learning system using the different National Institute survey that are realized during all the campaign. As you can see, during the campaign, there is different opinion polling, and they give the percentage of voice of each candidate and the voting share of each candidate. So we use this to train our system. And finally, training the system, we use several regression models. So we use LDA, random forest, SVM, CART, key network, and we look for the best result. Okay, as you know, we look for the lower mean absolute error. Okay, the cost function cost is MAE, and so basically it looks like that the best one was KNN. So we decided to use KNN to predict the result. So the last day, the day of the vote, we collect the tweets, which is very interesting because in that day we have no longer survey, we have no longer opinion polls, because you know by law 5 days before the campaign in Spain they are forbidden. You can't make opinion polls because you could influence the people, the citizens. So in Spain, 5 days before, you are completely blind. Okay? Blind because you can't call the people and ask what are their opinions. But they are still tweeting. So you are not blind if you are able to use tweets as a prediction system. And again, it's cheap, it's completely free. Okay? So the result, and it's my paper. So the result are that for each candidate, the winner was Pedro Sanchez, Left Party. The result he had was 28.7, and the last polls was 27.3. So difference of 1.4. But our system gives 29.2, which is a difference of 0.5%, 0.5. So it means that we get a better prediction result. We were closer to the real voting share of the winner. We had, for the last one, exact number as the official election result, but the polls were saying exactly the same. So we will reach the correct number exactly as the last polls 5 days before were predicting also. And finally, for the candidate in between, which we call them ballot candidates, which there is a lot of undecided voters that move from one candidate to another. Honestly, we had worse result than the polls. The polls was giving better result than what we have predicted using our tweets. So, bottom line, conclusion, we were able to rank the candidate in the correct order. We get better result for the winner than the polls. We get similar result for the last one as the polls, and we get worst result for the in-between candidate. But again, the ranking was okay. Our ranking was according to the result. So for digital marketers and political campaigners, our study could represent an important and cheaper tool, along with the traditional and standard survey, to gauge the strategy of their candidate and correlate it with potential voting share. In this objective, the dataset was created by mining Twitter for the days of the campaign, but future works could extend, try to optimize, and try to predict better. Also, we think that this framework should be used not only for the campaign, but all along the 4 years of the mandate, because it's one way to measure the politics, to measure how you are managing the country. And scientifically speaking, this study has implemented and compared different machine learning methods to determine the optimal technique, which was used to infer the voting share. And but as I say, future studies should analyze and propose better weighting factors to improve the result, and especially this debate that Twitter just represent the audible voice and the inaudible voice is not present, so it could make some misleading, could be the reason of this misleading, and could explain why we are not completely right. Okay, but I'm sure that we can find weighting factors that makes that in such way we can express, we can include the opinion of his inaudible voice, because the survey that are done by telephone have already included this kind of issue. So just to see how we can include this kind of factors in the social media analysis. Thank you very much, and that's it. And happy to answer to your question.